Alright, here we go. Writing formulas for ionic compounds. So let us start. Alright, so we have first here Na and Cl. So sodium, it has a +1 charge. Chlorine has a 1- charge. And so when we put sodium and chlorine together, Na plus and Cl minus, these charges are going to cancel out. So we're just going to be left with NaCl with a net charge of 0, which we don't put that on top. And so this is what we want for ionic compounds. We want the net charge of the entire compound, the entire sodium chloride compound, to equal 0. So with that knowledge, let us start this worksheet. Here we go, NaCl. NaCl. Next, let's try NH4 and Cl. Alright, so we have, this is ammonium. Ammonium. Alright, and this has a charge of 1 plus. Chlorine has a charge of 1 minus, and for the same reason like sodium, we would have a net charge of 0 when we combine one of each atom. So NH4Cl would be our answer. And note that because this is a polyatomic, so a polyatomic ion, so polyatomic, so it's a polyatomic ion, which means that it will have a combination of these two in order to make that ion. So we just consider that basically as one element for Chem 1 purposes. So you're not going to separate N and H4 into something else. You're going to keep it as NH4, and this collectively will have a +1 charge. So keep that to yourself. Remember that for your test. And note that because it's a polyatomic, you do need parentheses when you have more than one. But in this case, we only needed one molecule of the ammonium. So you do not need, you're not going to put NH4 in parentheses without any number here. So this, you're not using parentheses for this. But if you were to have some other anion here, like, I don't know, let's see, what could we think of? Something like, let's check the periodic table real quick here. Something like nitrogen with a 3- charge, we would need 3 for 1. And so here we would use parentheses, but in this scenario where we only have one NH4 ammonium molecule for each chlorine, we would not need parentheses here. Alright, so let's try potassium and chloride. So we have 1 plus, 1 minus here. So we know it's KCl, no parentheses, nothing, because none of these are polyatomic. So calcium 2 plus this time, and chlorine 1 minus. So we need 2 chlorines for every 1 calcium to cancel off these charges and make it 0, right? You have 2 on the calcium, you have 1 minus on the chlorine, so this gives us negative, or 1 still, and we need to do this again, -1 with 2 chlorines in order to get our desired net 0 charge on our compound. So we would need, for every 1 Ca molecule, 2 Cls, so CaCl2. Magnesium 2 plus, chlorine 1 minus. Same deal with calcium here. We're going to need, for every 1 magnesium, 2 chlorine. So 2 chlorines, so that looks like a bad M, MgCl2. Same reason, 2 plus, 1 minus, we would need Zn and Cl2. Let me erase that on chlorine real quick. Alrighty, and we have an Fe3 plus, so that's iron 3 plus. Let me scroll down a little bit. Alright, so with that iron 3 plus, we need 3 chlorines, because each chlorine is 1 minus. 3 minus 3 equals 0, so we need 3 chlorines. So we're going to have Fe, and then we're going to have Cl, and 3. So FeCl3. Same deal here, 3 plus, and we only have a 1 minus on chlorine, so we're going to have, for every 1 Al molecule aluminum, we're going to have 3 chlorines. Same deal here with cobalt, 3 plus, and our chlorine's only 1 minus, so we're going to have COCl3. Alright, this time Fe2, a different charge on our iron. So we're going to have, for every 1 molecule of iron with a 2 plus charge, we're going to have 2 molecules of chlorine with a 1 minus charge. So FeCl2. Alright, for hydrogen this time it has a 1 plus charge, chlorine has a 1 minus charge. HCl is your answer. Alright, let's move on to the second row, or second column. So sodium here, this time we have a plus 1 charge, and then we have this this polyatomic ion similar to NH4. This is called a carbonate polyatomic ion. So for every 1 sodium we need, one carbonate atom, we need 2 molecules of sodium because it has a 2 minus charge, and sodium only has a 1 plus. Therefore we need Na2, we need 2 atoms of sodium per every 1 carbonate ion, so it'll be Na2CO3. NH4 has a 1 plus charge. Carbonates has a 2 minus charge. We need two of the ammoniums to cancel out the 2 minus charge in carbonate. So we're going to have, this time we're going to use parentheses, NH4, close that parentheses off, and then you put your number there. So we need 2 ammonium for every 1 carbonate, NH4, 2CO3. K, so we have potassium here. K, we have a plus 1. Carbonate, we have a 2 minus. We need 2 potassiums per each carbonate. That'll give you K2CO3. And we have calcium here on the next one, and a CO3, 2 minus. They both have a 2 minus charge, so one of each will cancel the charge. CaCO3. Mg, 2 plus. Same deal with calcium, it has a 2 plus, and our carbonate has a 2 minus. So MgCO3. Same deal with zinc. Zinc 2 plus, carbonate 2 minus. One of each will cancel the charges, and we will have a net zero charge. And this will be it. Zinc carbonate, ZnCO3. Next, Fe3 plus. We have a 3 plus charge here and a 2 minus charge on carbonate. This is a little bit interesting, right? So we have Fe3 plus and carbonate, CO3 2 minus. So for every 1 iron molecule, 1 iron atom, we're going to need to use some of our knowledge, chemistry knowledge, to figure out that we need 2 of the Fe and 3 of the carbonate. So let me show you real quick. So we have an Fe with 3 plus, and we have here CO3 carbonate with a 2 minus. So in order to find the charge or the number of atoms needed to cancel these charges, we need to find the smallest number that both will go into, which is 6. So in order to do that, we need another molecule of Fe3 plus, which gives us a 6 plus net charge, and we need 3 CO3 2 minuses, which will give us a net charge here of -6, so 6 minus. So 6 plus charge on the iron, 6 minus charge on the carbonates, and that'll cancel this out to a net zero charge. So here we need 2 irons with each a 3 plus charge, and 3 carbonates, each with a 2 minus charge. Alright, let me erase this real quick, and we will write our chemical formula. So we said we need 2 irons, so Fe2, and we need 3 carbonates, CO3, 3. Remember to write our CO3 here in parentheses because this is a polyatomic ion. CO3 2 minus is polyatomic because it has a carbon and 3 oxygens. And we consider that basically one element, and we're just balancing the charges on it. So make sure to keep these in parentheses when you write the 3 there. Alright, Al3 plus and a CO3 2 minus, so aluminum here. Same deal with the iron here. We're going to need 2 aluminums per 3 CO3 molecules, and that'll give us a net charge of 0. So aluminum carbonate here, Al2 CO3 3. All right, cobalt here, same deal here. We need a 2 on cobalt and a CO3 3 on our carbonate in order to get the net 0 charge. All right, so we have an Fe2 plus here. This time the iron has a 2 plus charge, and coincidentally, carbonate also has a 2 minus charge. So we only need one of each, FeCO3. And note that we do not have parentheses here because it's on its own. We don't need 2 of each or 3 of each or 4 of each. We only have 1, so we do not need parentheses. And similarly, lastly, here on the hydrogen with 1 plus charge, carbonate has a 2 minus charge. So we need 2 hydrogens for every 1 carbonate, H2CO3. All right, let's go on to the third column. We have sodium 1 plus, and this is called a hydroxide ion. This is also polyatomic, and we call this hydroxide, and it has a 1 minus charge. So based on this information, we know that sodium has a 1 plus, hydroxide has a 1 minus, then we only need one of each. NaOH is our compound name. NH4 plus, OH minus, so we only need one of each, so we get a net charge of 0. So just write NH4, OH, no parentheses because we only have one of the ammonium molecule. All right, K plus, so that's potassium with the 1 plus charge, hydroxide with the 1 minus charge, one of each, KOH. Alrighty, calcium with a 2 plus charge this time with the hydroxide of 1 minus. So calcium, we need 1, and for every 1 calcium with a 2 plus charge, we need 2 hydroxides. 2 hydroxides with a 1 minus charge each. So make sure to use parentheses here because we have more than one OH molecule. Alrighty. Alright, Mg2 plus, same deal as calcium. We need, for every 1 magnesium, we need 2 hydroxides. Each hydroxide has a 1 minus charge, and 2 of them make a 2 minus charge, which cancels out the 2 plus on magnesium. Zinc 2 plus, we have Zn, same issue with magnesium. We need 2 of the hydroxides, so ZnOH 2. Iron this time has 3 plus, hydroxide only has a 1. So, we need for every 1 iron, we need 3 OH hydroxide molecules, and so it'd be FeOH3. Make sure to use parentheses here. Same reason, we have more than one hydroxide ion, which is a polyatomic ion. Excuse me. Al3 plus, same deal with iron. For every 1 aluminum, we need 3 hydroxides. So make sure to use parentheses there to get AlOH3. Same issue with cobalt here with a 3 plus charge. For every 1 cobalt atom, we need 3 OHs. Make sure to use parentheses. Alright, and 2 plus with the iron, which is the next question down. Fe, for every 1 iron molecule with a 2 plus charge, we need 2 hydroxides. Parentheses there also. Now this one, hydrogen 1 plus and an OH hydroxide 1 minus. Don't get these two confused. Hydrogen is the element H with a plus 1 charge, and hydroxide with a hyd for hydrogen and ox for oxygen. We have hydroxide being OH minus. So when we combine these two together, we're going to have HOH. You can write it HOH, which is like the organic chemistry way apparently, or you can also write H2O instead, which is water. Next up, we have the sulfate polyatomic ion, SO4 2 minus. So if we take a look here, sodium here has a 1 plus charge, sulfate here has a 2 minus. We need 2 sodiums per 1 SO4 molecule. Make sure to use no parentheses here because we only have 1 of the sulfate SO4 ion. Moving down, NH4 1 plus, ammonium 1 plus. We need 2 of ammonium. NH4, use parentheses here because we have more than 1, and SO4. So you should get NH4, 2, SO4 in the end. Potassium has a 1 plus charge here on the next row down. So each potassium cannot satisfy the 2 minus. We're going to have 2 potassiums instead with 1 sulfate, K2SO4. Calcium 2 plus, sulfate 2 minus. One of each suffices for the net zero charge, so you'll get CaSO4 at the end. Same deal for magnesium. One of each suffices with the net zero charge, MgSO4, magnesium sulfate. Alright, moving down a little, we have zinc 2 plus charge as well. We're going to have ZnSO4, zinc sulfate. Iron here, we have a 3 plus charge. Sulfate has a 2 minus charge. We learned earlier that for every, if we have these weird 3 and 2 numbers, we need to double it. So we need 6 plus on iron by doubling this. So we have 2 irons, Fe2. And to cancel the 6 plus charge we just made, we need 3 of the SO4s. So make sure to use parentheses, SO4, 3. You should get iron sulfate, Fe2SO4, 3. Next, moving down, aluminum. Same reason with iron here. We need 2 of the aluminums for every 3 sulfates, SO4, 3. Use parentheses here as well because you have more than one sulfate, and that is a polyatomic ion. Cobalt here has the same issue. We need 2 of the cobalts. That looks like an O2, so I'm going to redraw it. Cobalt here, CO2 and SO4, 3, which gives us cobalt sulfate. Iron this time has a 2 plus charge. Sulfate has a 2 minus charge. We only need 1 of each to get the net charge of 0. FeSO4 is your final answer. That's iron sulfate. Alright, this time we have a hydrogen with a 1 plus charge and sulfate, SO4, with a 2 minus. 2 of each hydrogen, which gives us a 2 plus charge, will cancel out the 2 minus on the SO4. No parentheses here, we only have 1 of the polyatomic ion sulfate. Alrighty, moving up back to sodium, and this time we have a phosphate polyatomic ion. That is phosphate. Let's just write this here, sulfate. This is hydroxide. And this is carbonate. Alrighty, so phosphate here has a 3 minus charge. It's quite special. So Na1 plus, we need 3 sodiums in order to cancel the 3 minus charge on phosphate, PO4. Na3, PO4 is your answer. Same deal with ammonium here. We have a 1 plus charge. Well, the phosphate has a 3 minus charge. Use parentheses. NH4, that's a horrible NH. NH4, close that parentheses off. We need 3 for each PO4. So we have NH4, 3 PO4. Potassium here has the same issue with the K, 1 plus charge, while the anion, the phosphate ion, has 3 minus. So we need 3 potassiums, K3, PO4. Potassium, phosphate. Moving down to calcium, we have a 2 plus charge here, 3 minus charge here. This time we need 3 calciums, Ca3, in order to get PO4 2 minus. So, PO4 2. And this gives us here a negative 6 charge, so 6 minus. Here we have 3 calciums, which each have a 2 plus, times 3 equals 6 plus. And these cancel out to have a net charge of 0. Your final answer, Ca3, parentheses, PO4, close that off, 2. Mg2 plus has the same issue. We need 3 Mgs for every 2 phosphates, which gives us Mg3PO4. PO4, 2. Same deal with zinc here. Zinc, we need 3. PO4, 2. Parentheses on all these because we have more than one polyatomic ion. Fe3 plus, we have 1 of each because each has a 3 plus and 3 minus respectively, so FePO4 is your answer. Al3 is the same deal, AlPO4. Cobalt has the same deal, COPO4. Each has a 3 plus 3 minus, and we're done. Next, moving down, we have an Fe2 plus. Fe2 plus, we need 3 Fe2s, in order to get our phosphate. So PO4, 2. That doesn't look like a very nice compound, so I'll draw that again. Fe3, PO4, 2. Make sure to use PO4 in parentheses. We have more than one polyatomic ion. We always use parentheses. All right, hydrogen 1 plus. We need 3 hydrogens in order to get net zero charge on PO4, H3PO4. Last column, we have Na plus, NO3 minus. This is the nitrate polyatomic ion. So we have 1 plus on 1 plus on sodium, 1 minus on nitrate, NaNO3. We are done. NH4 is the same deal. We have 1 plus on each, or 1 plus and 1 minus on each. So we only need 1 of each, NH4, NO3. This one's special. You might think it's weird because there's 2 polyatomic ions. And you might be asking, why don't we separate this like NH4 and then parentheses NO3? Well, we only have 1 of each. There's no need to do that. All the numbers fall to their respective ions and elements. So we do not need parentheses here. K plus, same deal here. We have 1 plus on K and 1 minus on NO3. So we have KNO3 as our final answer. Calcium as a 2 plus, NO3 as a 1 minus. We need 2 NO3s per every calcium ion. Ca, use parentheses this time. Write it like this, CaNO3, 2. Use parentheses because this is a polyatomic and we have more than one. Mg2 plus, NO3 minus. Same deal here. We need for every 1 magnesium, we need 2 NO3s and use parentheses. Zinc is also the same. NO3 right there. So ZnNO3, 2. Fe3 plus, we need for every 1 iron with a 3 plus, we need 3 NO3s. 3 NO3s, that sounds weird, but 3 times NO3, 1 minus. So that gives us a net charge of 0. And you have to use parentheses here because why? Obviously, it's a polyatomic ion, and you have more than one. Alright, moving down a little, we have aluminum 3 plus. Same deal here. For every 1 aluminum, we need 3 nitrates. Same deal, use parentheses. Same deal for cobalt as well. There's a lot. Wow. NO3, 3. Alright, Fe2 plus, and we have NO3, 1 minus. For every 1 iron molecule with a 2 plus charge, we need 2 NO3 molecules with a 1 minus charge. So FeNO3, 2 will give you the answer. Finally, H, 1 plus, NO3, 1 minus. So we need just HNO3 and we are done. Alright, that is your final worksheet answer here, and I'll keep that up there so you guys can take a picture or screenshot or copy it down. But yeah, that's it.